Good day, good people. In today's lesson, tikuenderera mberi circle geometry, but we are concerned focused on tangents. So those who are following us on our course reader, takushandisa New General Mathematics Book 4. Before we go into the lesson, ndoda kutanga nekudiscussa the idea of a circle. So the idea of a circle, I want to use it to answer the question, how many sides does a circle have? So how many sides for a circle? So when it comes to shapes, the first shape we have is obviously going to be a triangle, because in that case we have three lines which are connecting together. So this is a triangle. Then if we increase one side, could have a 4, it becomes a quadrilateral. Tika increase another side, could have a 5, so it's 1, 2, 3, 4. It's not going to be regular, just 5 sides. It becomes a pentagon. Toramba tichienda hexagon, heptagon, octagon, nonagon, decagon, dodecagon, and other fancy names. Toramba tichienda. What is going to happen here is, the more we increase a side, saka tingatiti side ichi n, and saka panapa n was 3, panapa n was 4, n was 5, panapa tosvika pa toramba tichiwedzera masides until we get to n is infinity. Patinoramba tichiwedzera masides kusvikira kuma unimaginable numbers, we begin to see a circle. Saka chinonzi circle, hama dzangu, kuwedzera masides pashape kusvikira masides ava closer to infinity. Saka a circle, we cannot say a circle is made up of only one side. No, a circle is made up of an infinite number of sides. That's the idea. But we can think about this as points, not sides. Saka we have different points. Of course, angakabatana ma points aya achitevera the same circumference, which are making up a circle. And this is going to be material by what we want to discuss next. So after understanding the idea of a circle, it's made up of an infinite number of sides. Infinite means unending. We are counting and counting until kingdom comes. Then we reinterpret my sides as points. So kuti pataka define a diameter. If you remember well, ndakatsanangura ndichiti, a diameter, we have a line which is connecting two opposite points. Saka tine point panapa A, toita point panapa B. Saka diameter inoconnecta ma opposite points aya but ichipfuura nepa center O. That's what a diameter is. So every point inside this circle is going to be connected, or rather it's going to have an opposite point in the opposite direction. That is what we want to talk about. But the essence of this lesson is focusing on the tangent. What is the tangent? By definition, a tangent is a straight line. So ndo patinotangira panapa. This is a straight line which touches a circle on one particular point. And what does this mean? This means does not cross the circle. And there is a gory term I use, dinoti kunanza, for my students to understand. Saka, in layman terms, tangent, a line, straight line, rinonanza circle. Saka rinongonanza on one particular point. If we have a circle like this, we have a point like this. A tangent is going to be a straight line inongopfura nepa this point chete. And it might not be your first time hearing about tangents if you did the topic quadratics, where we used a tangent to approximate, to calculate the gradient of a quadratic curve. So this is the same concept. A straight line which touches a circle on one particular point. That is what a tangent is. Now, after understanding the tangent, our book goes with us through a proof. It develops this theorem and proves it. We are not going to do that, but I still open floor to those who want to pursue that, to communicate via comments or via our contacts, so that we can focus on that. But it's immaterial to our syllabus. That's why we are not focusing on that. What we rather want to focus on is the tangent theorem. So this is rather theorem number 1. In our listing, it should be theorem number 5. So maybe let us just call it theorem. Is it number 5? We did how many theorems? Let us do a quick revision of the theorems, just citing them so that we know Ktaba theorem number 1. So the first theorem we did, we were talking about the point at the center, angle at the center, being twice angle at the circumference. This was number 1. Number 2, we spoke about angles in the same segment being equal to each other. This was theorem number 2. Number 3, we spoke about angle in a semicircle being 90 degrees. That was our number 3. And let me just put a number 4 panapa. Yes. Number 4, we spoke about cyclic quadrilaterals, opposite sides of a cyclic quadrilateral being equal to added up being supplementary. If this were a C and D, C plus D is equal to 180 degrees. Then we can talk about a 4A. 4A, we learned about it in hindsight. If we have an external angle external to a cyclic quad, if we have this angle theta is going to be equal to an opposite interior angle theta. So this is a 4A, not a reinterpretation, but rather it's just an additive to theorem number 4. So this is a rough explanation. You can find it in our earlier videos in this cluster 19 psychogeometry. We learned about all this in detail, I would like to assume. Saka, we are now doing theorem number 5. What are we going to learn per theorem number 5? Theorem 5, as we read it, a tangent to a circle is perpendicular to the radius drawn to its point of contact. I cannot stress how important this theorem is. Theorem irikuti, if we have a circle and we have a tangent, then tovane is the center of the circle, Then we draw out a radius. Remember what a radius is? Line rinobva pacenter richindobata circumference. That's the radius. Panosangana this radius and a tangent, it's always going to be 90 degrees. Kureva kuti radius and tangent are perpendicular always. Saka kana vachitesta this, which they usually do by the way, they don't usually give you a neat illustration like this. They would do something like this. Then vongokanda tangent yavo chero with a line like that. Saka the moment you make up kuti this is a tangent, how do you see it's a tangent? Rikunanzva circle only at one point. Kana kuti harisi kudambura into the circle. And then you establish kuti you have a radius. Before you even answer anything, remind yourself, just come and put a 90 here. And remember, kana pana papa ini 90 kuside uku kune 90 foot. Saka it would depend like the structuring of the question kuti 90 ipiri most useful. But that is very important. Zvikoshiwa is very, very important. Okay? Tangent, the perpendicular to a tangent at its point of contact passes through the center of the circle. This is a reinterpretation, a rewrite of theorem number 5. And let me emphasize again. The wording, the jargon does not matter. How to apply matters. So it's either you think about it as the tangent of a circle is perpendicular to the radius drawn to its point of contact. Correct? We are defining this theorem from the point of view. Of course, it's inanimate, it doesn't have a point of view. But from our understanding is coming from the tangent. Then the perpendicular to a tangent at its point of contact passes through the center of the circle. We are now focused on the radius. So that is going to be it. Let us see if we can learn anything from example number 1. So example 1, TA is a tangent at A to a circle. Center OAB is a chord. If BAT is equals to x degrees, show that BOA is equals to 2x degrees. Questions of showing are not commonplace. But since this is an example, let us take it as a question. So we have a circle. This is O, which comes here, and this is the tangent TA. Then like this to Dzikapano, like that. So this is X. Saka panapa it's A, upper it's B. Let us look at the question again. TA is a tangent at A. So this is the point A to a circle center O. AB, that line, is a chord. And if BAT, so BAT is equals to X, show that BOA, whatever this angle is equal to 2x degrees. So we want to find out what this angle is going to be. Okay. Question yama dzangu yakakosha. Nekuti iri kutiratidza zvinhu zvakakosha. And rega ndiprove kukosha kwayakaita. Saka let us treat this. Tiri kutsvaga this angle. And tatoudza kuti the answer is going to be 2x. Saka tanziti prove. But we can treat this question as if tiri kutsvaga for the first time. Remember what I told you. If you have two radiuses, you should always know kuti kana tine two maradius, kozoita rimwe line, zviri mu triangle, that triangle is isosceles. And the moment the triangle is an isosceles triangle, what does it mean? The base angles are going to be equal. Saka tisataenda kure, I will put a line panapa nepanapa, which is telling me that this is an isosceles triangle because iri radius iri OB and also OA is a radius. So that's a trick part inotadzikwa nevanhu vakawanda. Then the second part here, we want to apply theorem yatabva kuita. Theorem yatabva kuita iri kuti if we have a tangent and a radius, zvichisangana, what do we make? 90 degrees. Kureva kuti pana pesa apa engo yese in 90 degrees. Saka we can actually write it down with OAT is equal to 90 degrees. And the reason we can put here, remember the reason is to communicate to the examiner, but more so to communicate to yourself. So the reason we can put here for this theorem, tinogona kungoti radius and tangent perpendicular. Saka that's our reason. So musungiro kisa ma reasons ndinomaisa to communicate with the examiner. In case ndatadza saka I need part marks, at least if I show kuti ndema principles and apply correctly, I might get half a mark or something. Because the idea of an exam is to get as many marks as possible and hope to God that those marks are going to be a pass mark. Okay. Saka OAT it's 90. But we know kuti TAB is equal to X. Like takatozodzwa TAB. Yet we can rewrite OAT as TAB plus kasmo pataka kanike karichi BAO. Let me give flesh to this. Saka tirikuziva kuti kubva pa line iri tichiuya pa line iri it's 90 degrees. But knowing that it's 90 degrees, we also should appreciate with part of 90 the X. Saka isusu toda kuziva kuti kaengo aka ndiani. So this statement randanyora apa riri kungobva pakuti OAT, which should be 90 according to the theorem 5 yataita, it's broken down into two parts. The other part is already X and the other part we don't know it. Saka part yatisiri kuziva ndeyani ndi BAO. Saka BAO after rearranging inenge iri equal to OAT minus TAB. I really wish it makes intuitive sense. Saka BAO iri equal to 90 dzepesa apa, which is OAT, minus X dzingori pa this little part like this. Saka angle E inenge irichi 90 minus X. You are going to find situations where you have to find angles as expressions. And you should always know compacting expressions should be put in brackets when you are using them. Saka, since this is isosceles, base angles are equal to what panapa, it's also G, 90 minus X. Saka kana tine two angles inside the triangle, tichida the third angle, which is angle yatiri kutsvaga panapa BOA. What do we do? Of course, we know kuti takushandisa 180. Saka I can write like this. Negenda kuti BAO, which is angle E, plus ndakuda angle E, which is from our question yanzichi BOA, yeah, BOA posindo yatiri kutsvaga, plus ndakuda this angle which we can call ABO. Remember later pakati ndo inofanga iri pa angle yacho directly. This should be equal to 180 degrees. Trikutsvaka BOA, saka S is custom, we make BOA subject of formula. How do we do that? Everything goes that side becoming negative. Okay. Then panapa, we now need to replace or substitute. So BAO ndiani ndi 90 minus x. Ko ABO ndiani ndi 90 minus x. Saka zora tiri kuti BOA panapa is equal to 180 minus bracket, don't forget brackets, 90 minus x. Panapa yoita futi minus kureva e toisa futi bracket 90 minus x. Let us solve this. Tono kuti zvinotibuditsira 2a here. 2x that is. Saka tichati 180 minus times 90 and minus 90 minus times minus x and plus x, and then minus times 90 and minus 90 minus times minus x and plus x, like this. Saka BOA iri equal to, mukacherechedza muchaona kuti minus 90 minus 90. Remember kana tichisubtracta minus 90 minus 90, we add and take the common sign. So 90 plus 90 ndi 180. Kureva kuti tikanyora this 180 yagara iripo inenge iri ichitishi minus 180. Then x plus x ndiani ndi 2x. Saka BOA is equal to 2x. Because 180 minus 180 is 0. Saka we have proven that that is going to be the answer. So that is how it's done. I was working through this. If you follow the working in the book, they came to the same conclusion with BAO ndi 90 minus x, ABD ndi 90 minus x, which is the crux of this question. If you know that you've cracked it, panapa wavazongoti minus 2 times, which I fed off because I don't like using it like that, but we get to the same answer. So that is it for our theorem number 5. Let us go through, let us discuss example exercise 3a. Saka discussing, remember, tinogona kuita ma questions atinge tida kubatsirana, but most of the questions I will just be giving you hints and walking off. Saka you have to be ready for that. But mukaita question yamunofila kuti ndangachifangwa kuiweka, you can communicate in the comments or directly to us. So 3a, the question is calculate the size of the angle in alpha in each part of fig 3.6. In each fig, O is the center. Saka yekutanga ndiite because this is radius and tangent, crowd this is 90. Kana mine 2 angles inside a triangle, mchida the other angle, you should know what you have to do. To enter pa question B, I want you to do a research on this one. It's a very important question, by the way, but you should know you have set angles because of this system of parallel lines with the transversal line. So somehow you should be able to use set angles to find what you are looking for. Then C hapana zvatichaita because tukoona kuti radius tangent saka 90 tane 2 angles inside a triangle saka alpha ifangonetsa kuwana. Then when we go to part D inotudza kuti we have 90 panapa because that's where we have the radius and tangent. Then we also have panapa, it's going to be 160 angles on a straight line, and saka taona kuti apapa it's 160, apo it's 90. How are we going to find this? So homework, I gave you enough hints. I would recon, because we simply need to find out what this angle is going to be so that we can use 360 as the sum of angles in a quadrilateral to get alpha. Let us go to number 2. It would calculate the size of theta. Let us go to number 2. It would calculate the size of theta in each part of fig 3.7. In each fig, O is the center of the circle. Saka theta painetse, it's simply 90 minus 54. We illustrated it in our example. Then kopanapa haifangwi kunetsa futi, because the moment we see this, and in fact tikadzokera pa D, you should also take note kuti my lines are going to be equal to each other, since SR ma radius. That might be material to what you want. And panapa again, saka this is a system of radii. So good, I'm feeling some type of way. Ngatite D, because D illustrate as an anchida. I don't trust to be able to pick it out as homework. Okay, so reproducing this, we have a point, then a radius, then panapa tina O, diameter, alright, point yedirapa. Saka, then tovataita another line rakudaiso, and another straight line rakadai, and yes. Towards what pan about it's 20. Apa pando pane alpha ya kutsvaga. This is O. Saka chekutanga kuita take note of my radius edu. This is equal to this, also equal to this. Saka tikatora this radius, which is kubva pa O kubata this part of the circumference, ne radius E. We see kuti this is a triangle, kureva kuti it's going to be isosceles. Saka naira isosceles panapa ichi 20. And it base angles are equal. But kana iri 20 zorota apa ichi apa 140 kapa. 140 ta wanna say tangoti 180 minus 40. Tango shandisa sum of angles inside the triangle, which I believe you know how to do it. But angles on a straight line, panapa it's going to be 160. Then panapa, of course, it's 90 due to our theorem. And what about panapa? Panapa is going to be 40. Sakatavana 90, 40, 160, tudatsvaga alpha. But before we go anywhere, there is a property of isosceles, not isosceles, but just triangles I want you to know. Kuti, if we have this angle theta, panapa ngatiti it's alpha and beta. This external angle theta is going to be equal to alpha plus beta, like this. You have to know this. Saka pata apply panapa 40 uyarungobva pana 20 plus 20. And saka that's another property. So this was discussive, atina kuita step by step, but I hope explanation yang pa D yakuratidzai answer mune wanna say. Then panapa, this is just the remainder from 90, since this is a radius and that's tangent. Saka and 40. Zoreva kuti angle yatiwana panapa ingotongori yakafanana na theta. So when you are dealing with now the radius, it's be on the lookout for isosceles triangles. Please, as you can see, everywhere we are using isosceles triangles. Then ino zvakare iya inetsikwana kuroti iya inetsikwana. Ine maka isinganetsikwana pesa pa 90 kurova kuti iyi inge ingori 90 minus 62. Go figure. Then so that apa it's going to be let me do D. So this is the circle for D. This is our tangent, and O todai so, then todai panapa todzo tichi theta. Saka kana pari theta mukatuminge menge murichi 90 minus theta. But this is a radius, this is a radius. Kurot panapa vutichi in 90 minus theta. But panapa tatodza kudara kuti ndi 140. Kuroti theta ngarichi 140 plus 90 minus theta plus 90 minus theta is equal to 180. Saka this is 140 plus 90 minus theta plus 90 minus theta is equals to 180. Minus theta and minus 2 theta. 90 plus 90 and 180. Andika. Then 140 ngoramba yakadaro. This is equals to 180 and tikaendesa 180 iyi kuside uku. So rot tingeta kuti 140 degrees minus 2 theta is equals to 180 minus 180, which is 0. So 140 degrees minus 2 theta is equals to 0. Tikaendesa 2 theta uku. So rot iningere 140 is equals to 2 theta, which means kana takuda kusarana theta, we just find the half of 140, which is 70. Saka theta is 70 degrees. You see? That's how it's used. Saka we have helped each other through that. Number 3, calculate OAE in each part of fig 3.8. Each figure, O is the center of the circle and the dimensions are in centimeters. Saka panapa vangoda kuti tsvage Pythagoras. I am not going to go through this. We have an extensive library of trigonometry. We did trigonometry at a level I believe most people haven't reached. Saka this is 90 and this is a right angle. Saka tsvaka hypotenuse. Then this is 90. Panapa tsvaka AE through the hypotenuse kana kuti Pythagorean theorem. Saka number 3 tatoita number 4. In fig 3.9, O is the center of the circle, TA is the tangent at A. Then intoda kuti muite as your homework. Inotesta zvatanga tichiita. Inotesta angle placement. Kuti mozivaira kuti angle inoverengwa sei inoiswa papi. And this is a very important question. Chero mukatadza kuita zvimwe zvese zvataita izvi, but number 4, please make sure you do it. Very important. Let me put stars there. It's a 5-star question. Ino summarize everything. So I'm leaving the delicacy to you. Then you can elect to do these ones. Circle geometry mawira inoita in almost every case inoya iri a diagram and you have to fill in angles. But my questions are important. Asingakupe a diagram because they test intuitively if you have mastered conceptually the topic. Saka, you can just do them as part of your practice, but we are not going to look at them. So that said, let us come to number 9. Saka 9 iri kudei. Saka pana pasataenda kure radius since apa iri x soroti apa pandi 90 minus x. Saka pana pa anga ari vurichi 90 minus x. Saka tombeenda kure tenge tatoonera zvinizvi. Then pana pa it's also 90 like that. So what is it this question wants? If BAC is x, find OBA, and which is a 90 minus x, ABC, okay, which is this angle, and in terms of x, sakatatoziita. Then this second part of showing that AB bisects OBC, AB bisects OBC. We just have to prove that this angle and this angle are equal. It's immaterial to our syllabus. So we have done this exercise. But what I want to emphasize, dear people, is this. When you are doing these questions, pese patrikuita ma discussions aya, the aim of my discussions is, we have seen if we follow every question, we won't cover much ground. Saka, the way I teach this topic, my discussions, they are to prompt your understanding. Imima amu discuss these things. You take pen and paper and you work through every question. Kutanga ma questions andanga ndichingotaura. moona kuti anobuda here. Secondly, ma-questions atati ma-homework. Then if you have extra time, you can go for my research questions. You understand? So that is something you should be familiar with. Saka, let us meet in our next lesson. Tichita tangents from an external point. Very important. Vitally. Very vital. Saka, just what we are going to be doing in our next lessons, tichaita this theorem, then conduct of circles, tichango batao. It's not as much examinable. Tichango batao. Conduct of circles, tichango kungobatirawo pamsoro. Otherwise, this is very important. Alternate segment, and that is what is very important. After which, tinengeta pedza our lesson. So in our next lesson, we are going to do tangents which have a common point outside the circle, tangents from an external point. Then tinojamba conduct of circles, because it's not that much material. Toenda ku alternate segment. Tinenge tapedza zvakanyanyo kukosha pa-circle geometry. Otherwise, thank you for your patience and thank you for being with us throughout this lesson. If you need extra lessons, we are available, but you have to contact us on these two numbers. So +263, that's the Zimbabwean code. You contact us via WhatsApp. +27 is a South African code. You can also contact us via WhatsApp. So these are the two numbers you have to hit us on if you are in need of extra lessons. Otherwise, Godspeed and great luck to those who are writing their finals soon. Thank you.